This is from the unit review, putting it all together. So out of these 5 reactants, we're going to figure out if they are going to have a double replacement reaction happen. So we are going to use our solubility table, this guy, and see if a reaction runs and we form a precipitate. So let's use NaCl and silver nitrate and see if this happens. So the Na is outside, so it's going to join up with the NO3 because he's a positive and he's a negative. And then the chlorine is a negative and the Ag is a positive. So we're going to end up with Na plus 1, NO3 minus 1. So those charges are going to cancel. And our second compound is going to be AgCl, and we're going to write Ag first because he's positive, so we always start with the positive. He's a plus 1, chlorine is minus 1, so they end up canceling. So now we're going to use our solubility chart to see if this reaction happens. So our first compound is NaNO3. So Na is in group 1, and they're all there, and they're all going to make an aqueous solution. So this is going to be an AQ. Our next compound is AgCl, so silver chloride. So silver is here on the chart. So we're going to draw that line across. Chlorine, nitrate, acetate. Here's chlorine. So where those match up, we see our S for solid. This reaction is going to run because we've got our precipitate formed. So next we're going to write the complete ionic equation. So we're going to break everything that is an aqueous solution into its ions. So Na plus 1 plus Cl minus 1, because this is aqueous and this is aqueous to start, plus Ag plus 1 plus NO3 minus 1. So that's our reactant side. Now we're going to look at our product side. We can't break our precipitate up. So all we're going to break up is the Na plus 1 plus the NO3 minus 1. And then we've got our precipitate, AgCl. So now we're going to find all the spectator ions, the ions that we see on both sides of the reaction, both on the reactant side and the product side. So I've got Na on this side, Na on this side, NO3 on this side, NO3 on this side. So now I'm identifying my spectator ions, and I'm not going to write them in my net ionic equation. So I'm going to go Cl minus 1 plus Ag plus 1, and you can flip-flop those and start with your silver. And then we've got our precipitate, AgCl, and he's a solid. These guys are aqueous on this side, and that is your, so we've got our complete ionic, where we've written everything out. We've got our net ionic with our spectator ions booted, and that is a double replacement reaction, and we have to have our precipitate formed. So let's look at one more step. So let's do calcium chloride and zinc bromide. So these two are going to react. We're going to end up with our outsides together and our insides together. Let's do some charges now. Charge on calcium plus 2, charge on chlorine minus 1, charge on zinc plus 2, bromine minus 1. So we're going to end up with calcium bromide, CaBr, the plus 2 coming from the calcium, minus 1 for bromine. So we're going to end up with 2 bromine when we crisscross our charges. Second compound is going to be zinc. Start with that positive first. Chlorine. So zinc plus 2, chlorine minus 1. We're going to end up with 2 chlorine when we crisscross. Now we're going to go to our solubility chart. So our first compound is calcium, who's here, and bromine, who's here, and they're going to form an aqueous solution. Next one is zinc and chlorine, so find zinc, zoom, 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 all the way across. Chlorine, Cl is here, and that's another aqueous. Because we have no precipitate here, this is not going to be a reaction. So let's do one more where we can actually do the net ionic. So this time let's try calcium chloride and aluminum sulfate. Plus 2 on calcium, minus 1 on chlorine. Aluminum is plus 3. Sulfate is minus 2. So we actually need 3 sulfate there. So we're going to do a flip-flop with our cations and our anions. So calcium is going to end up with SO4 sulfate, plus 2, minus 2. Don't need to do any subscripts based on our charges because they cancel. Then we're going to end up with aluminum chloride, plus 3 on aluminum, so that's going to drop down to the chlorine, minus 1 from the chlorine. We're going to only end up with 1 aluminum. Let's check and make sure that this reaction actually goes. So calcium sulfate is our first one. So calcium and sulfate. That is a solid, so we have a precipitate, which means we have a reaction. Let's check aluminum chloride. Here's aluminum, here's chlorine. That's our aqueous. So we've got a double replacement reaction here. So now let's do our complete ionic. So we're going to break all these guys down into their ions. If it's an aqueous, if it's solid, remember we don't break it down. So calcium plus 2 plus chlorine minus 1, but we've got 2 of them, so that coefficient comes out in front, plus aluminum plus 3, and we've got 2 of those, plus our SO4, we've got 3, he's got a charge of minus 2. Then we come over here, our calcium sulfate is our solid, so he's not going to break down. So we're going to end up with Al plus 3 plus our Cl minus 1. Sorry, I ran out of space. So our spectator ions, again, we're going to find them on both sides of the reactions. Aluminum and chlorine are still ions on this side, which means they're ions on this side because everybody's an ion on the reactant side. So there are spectator ions, so we're going to get rid of them when we go to do our net ionic equation. So we've got calcium plus 2 plus our SO4 minus 2. That goes to our precipitate. And these are both aqueous on this side. I hope this helps. Please study for your test tomorrow. And I will see you guys then. Bring any questions you have, or email me, or use Remind and text me.